In this particular session, we will study about Ampere Circuits Law, its applications, and we will do mathematical problems. Let's see if we can finish all these things within this period itself. So let's see what do you mean by Ampere Circuits Law? So Ampere Circuits Law states that the line integral of H. So you say line integral of H around a closed path. So this is a closed path, it's carried. So line integral of H around a closed path is equal to the current enclosed by the path. So what does Ampere Circuits Law state? The line integral of H around a closed path is equal to the current enclosed by the path. So if this is a closed path, then the current enclosed by the path is equal to line integral of H dot dl. So H is the magnetic field intensity. Then you know that by Stokes' theorem, integral H dot dl is equal to surface integral of del cross H ds. So Stokes' theorem we have studied in module 1, we have derived it. So we know everything about Stokes' theorem. What is the physical meaning of curl? Everything you have studied. So all these things you should come into your mind. So magnetic field is coming out. So I'm not going to what is curl and its significance. Go back and see when you study. So all these things will should come into your mind when you study these things. So integral H dot dl is equal to surface integral del cross H ds. And also you know that current enclosed is equal to surface integral of J into ds, where J is the current density. You might have studied J is equal to I by ds. Yes, we have studied this. So we have equation number 1, that is integral H dot dl is equal to I enclosed, which is the Ampere Circuits Law. And by Stokes' theorem, we have the relation integral H dot dl is equal to surface integral del cross H ds. That is equation number 2 over as J dot ds. That is equation number 3. So by comparing equation number 1, 2, and 3, we can write del cross H is equal to J. Yeah, from this you will get it. You will substitute here and you will get H dot dl, just substitute. So this will become J. So this, when you compare 2 and 3, that means del cross H should be J, which in turn is equal to I enclosed. So we get del cross H is equal to J. So that's what we get it as. Del cross H is equal to J. This is one relation and we call it Ampere's law in differential form, or we also call it Maxwell's third equation. So Maxwell's first equation, second equation we have already learned. So I will just summarize all the 4 equations once we finish the 4 equations. Because normally, if you say to somebody that you know electromagnetics, the first thing that they ask is what are the 4 equations of Maxwell? Okay, so that will just summarize. So you get del cross H is equal to J. Okay, so it is called Maxwell's third equation. Now we will prove. So maybe in your exam they will ask you state and prove Ampere Circuits Law. Then it's a very simple proof. We'll just see. So we'll consider the X conductor in the Z axis, and you have the angle phi. It is along which is tangent cylindrical coordinates, Cartesian coordinates, and all we have seen. How r, theta, phi, and all vary. How it is coming, and all we have seen. Now we'll go ahead with the proof. So what we normally do, we consider a small length, right? So the small length dl is equal to r d phi a phi. Similar, why it is r d phi a phi? Because here the radius r is a constant and z is also a constant because we are considering it on the surface itself. Same way. So dl will be r d phi a phi, and we know that for a finite line conductor, we have derived the very first derivation where we did by using Biot-Savart's law. What is the equation? Magnetic field intensity H is given by H is equal to I by 2 pi r into a phi. You might finite length alpha 1 will be 190 degree, alpha 2 will be 0 degree. So depending upon how you give the name, one angle will be 190 and another one will be 0 degree. Then if we got it. Okay, so you have this here. Now, what does Ampere Circuits Law say? Ampere Circuits Law says that H dot dl, the closed integral of H dot dl is something, right? So we need to find out that it is I enclosed. Then we say it is proved. Now we do H dot dl, and H is some value divided dot Fi. So Fi dot Fi will be 1. So I will do it here itself. In place, H dot dl will be equal to I by 2 pi r into r dot d phi, r into d phi, right? A phi dot a phi will become 1, a dot b. So a b cos 0, same concept, h dot dl. Now we will do closed integral h dot dl. So that is what the Ampere circuit law says. So first of all, we found out h we already found out. Then integral h dot dl is equal to I by 2 pi integral 0 to 2 pi, because from here I am doing I by 2 pi into r d phi. So this we need to do the integration. So this we need to integrate. That's what Ampere circuits law says. So this integration means I r by 2 pi r you can cut. So it will be I by 2 pi integral. So value of phi will vary from 0 to 2 pi. From the very beginning we are studying 0 to 2 pi. So I by 2 pi integral 0 to 2 pi d phi is equal to I by 2 pi into 2 pi. That means 2 pi gets cancelled. So we proved integral h dot dl is equal to I n l. Then one property the Ampere circuits law the Amperian path it need not be always a circle. It should be any closed regular surface. So Amperian path can be any closed regular surface. And Ampere circuits law is a special case of Biot-Savart's law, where integral h dot dl is considered I enclosed, and we proved that. Okay, because it's a special case because we use the Biot-Savart's law result here of an infinite conductor, and we proved that in that case integral h that magnetic field intensity h dot product with dl over a closed surface is becoming equal to I enclosed. That's what we mean. That's what's about Ampere circuits law. Now let me know if you have a. Now we will see what are the applications of Ampere circuits law. So by using Ampere circuits law, how we will calculate. When we studied electrostatics, by using Gauss law, we calculated the ring, like that we calculate. All these things are it's there available recorded as well as in the notes. The second module notes also I will give you. Yeah, today I will upload. So everything is already there with you. So application of Ampere circuits law. First one, to find the magnetic field intensity H due to infinite long straight conductor. So by using Ampere circuits law, how you will find out? Just compare and study module 2 and 3, then it will be very easy. Like if you study 2 and 3 separately, it will take you more. It will take you double the time. If you study compare and study, it will take you half the time. Like half the time of studying it separately. So make sure that you compare and study module 2 and 3. Okay, now we will move on to the derivation. So we will consider the x, y, z plane. X, y, z plane. And then we have, so we will consider please wait. So this will be the straight conductor that we are considering. We'll consider a conductor here, infinite length conductor. You will consider same type, and then we'll consider what is this? Don't get confused. So what will be this? I'll use another color. So we should first of all, like in Gauss law, we should consider a Amperian path. There we took a Gaussian surface. Here we should take an Amperian path enclosing the current carrying conductor. That is what Ampere's law states, right? Integral h dot dl is equal to I enclosed. So we consider an Amperian path and a point P here. So we need to calculate the electric field intensity at point P on the Amperian path by using the Ampere circuit law. Okay, let's see. So similar. So we have d phi here. All these things just like before, and this is the Amperian surface we have taken, and this distance is r. So it is at a distance r, and O is the origin. Then just like in all the other derivations, the small length dl, that we are considering is equal to r d phi a phi Similarly, the magnetic flux density H, magnetic field intensity H is equal to H phi A phi, because the same reason here, radius is constant and Z is equal to 0, because for infinite length Z was like it is on the surface only, so Z is equal to 0. Then by Ampere circuit law, we have integral H dot dl is equal to I. Now it's all about taking H, you do H dot dl and then integrate. So you should be well thorough with integration. Don't worry, just study whatever integration we are doing here. So that's all required. Just try the derivations 2-3 times, understand and learn the derivation, then it will be fine. Okay, so H dot dl we are doing. So H dot dl, when you do, the AFI will not be there, all these things you know. So it will be integral over R, then it will be H phi dot d phi integral 0 to 2 pi, right? I have skipped one step here. I hope you understood. H phi dot d phi is equal to H phi into R into phi 0 to 2 pi, because these steps we are doing all the time. H dot dl already we have done in one derivation, so that's why I skipped one step. So H phi into R into 2 pi. So you will get H phi into, so by H dot dl we got it as H phi into R into 2 pi, and so that is equal to I. So H phi into R into 2 pi is equal to I according to Ampere Circuits Law. Then I is equal to, from that we will get I is equal to, no, from that we will get H phi is equal to I by 2 pi R. Therefore, we can say H is equal to, you already know H is equal to H phi into A phi, right? The direction also we should write. So it is I by 2 pi R into A phi. So by using Ampere Circuits Law, we calculated what is the electric field intensity for an infinite length of the conductor. So here we have given a region is given which is lying between 0 to 0.5 meter in cylindrical coordinates. So remember the cylindrical coordinate, how it is coming and all you should have in your mind. Then current density is given as 4.5 into e raised to minus 2r along the Z direction. Unit is ampere per meter square, and J is 0. So the value of J is for this particular region, and for other region it is 0. Now we need to find H using Ampere Circuit Law. So we have J is equal to 4.5 into e raised to minus 2r into AZ ampere per meter square. And since it's a cylindrical surface, just recollect, cylindrical surface differential length. We have studied dr, dz we have studied, then r d phi. I hope you remember these all things we made clear for you. So here also we should know the H dot, well, Ampere Circuits Law means we should apply H dot dl. So we need dl. So here it is surface ds only. So ds is equal to dr dot r d phi az, because the current density is given along az. That means this should also be dr r d phi az. That's where we should take the Amperian path, and we know that I is equal to integral j dot ds. So the base for all this calculation is what? Integral h dot dl is equal to I. So first of all, we are finding out what is I, because in our question they have given us current density. From that we need to calculate what is I. In order to calculate I, we need ds. That is what ds we have calculated now. So I is equal to integral over j dot ds. So now we need to do integral phi is equal to 0 to 2 pi integral R is equal to 0 to 0.5 because we have d phi as well as dr. So both the limit for R is given and phi you know it will be from 0 to 2 pi. So you substitute it here 4.5 into e raised to minus 2r, which is 4.5. Don't take 4 into 5, it is 4.5 into, okay. So 4.5 into e raised to minus 2r into a raised to z dot product with dr r d phi a z. Okay. Now it's all about calculation. So 4.5 you will take common is equal to 4.5 integral phi is equal to 0 to 2 pi integral r is equal to 0 to 0.5 r into e raised to minus 2r into dr into d phi az dot az it will become equal to 1 and 4.5 integral phi equal to 0 to 2 pi d phi, then integral e raised to minus 2r into dr. Okay, integration by parts. Okay, now we have integration by parts. Integral r into e raised to minus 2r. So those who don't know integration by parts, just refer and see. Okay, integral x and coefficients integration integral of first term into derivative of integral. So r into e raised to minus 2r into dr. How to do integration by parts. Okay, so this is operation we are doing. R into integral e raised to minus 2r into dr into integral of r. Sorry, integral of derivative of r into integral of e raised to minus 2r into dr into dr. So 2 dr will come. Okay, so it will be just refer this formula. Okay, then you will understand if you are not following the calculation. So 4.5 into 2 pi into r into e raised to minus 2r minus 2 minus, it will be e raised to minus 2 integral of e raised to minus 2 is e raised to minus 2 by minus 2 into, again that dr will be there, so 2 drs will come. Try to find out the integration by parts formula and do it yourself, because that will be effective learning. So everything I should not teach you. You should find out something on your own and do it. And then still you have doubt, you can ask me, because many of your friends are still in the beginning. Many of you were asking me doubts. Now only 1 or 2 are regularly sending me doubts. So same way you can also send me and learn effectively. So 9 pi r into e raised to minus 2r by minus 2 plus 1 by 2 into e raised to minus 2r by minus 2 integral 0 to r. This 0 to r. 0 to r is 0 to 0.5 only, right? 0 to 0.5. R is equal to 0.5. Already we have written here. So this calculation. So be careful when you do the calculations. So 9 pi by 4 minus 2r into e raised to minus 2r. So you do on your own. Maybe even I can get wrong. I have calculated in my notebook. So even maybe I have also some steps. So you be careful when you do it. Do it on your own. So I is equal to 9 pi by 4 minus 2 into. So now we are substituting the value of r. R is equal to 0.5. So minus 2 into 0.5 into e raised to minus 2 into 0.5 minus e raised to minus 2 into 0.5 plus 1. So finally you will get it like 1.8676 ampere. That is only the I enclosed. Then again you go for integral h dot dl is equal to I. So integral phi is equal to 0 to 2 pi h phi dot r d phi is equal to I. Then R you can take common. R into H phi integral phi is equal to 0 to 2 pi d phi is equal to 1.8676. So from this, you will get H phi is equal to 1.8676 by 2 pi r. And all these values you can substitute 2 pi r and everything. You can substitute. So finally, you will get 0.29722 by r. The value of r you can substitute. A5 ampere per meter. Okay, so this is how we calculate the electric field intensity by using Ampere Circuits Law. So initially only J was given. So this can come as a 10-mark question. Short 10-mark question, because this exam will be normally 80 marks will be should be numericals only if it is a tough question. So 80 maybe 60 or 60 to 80 will be problem. So this can, they will directly just ask this 2 sentences they will ask, and it will be 10 marks. You need to find out the electric field intensity. J will be given. So this is how you should do. So I think these steps and all everyone will do, but you should be more careful when you do the integration and all. For that, you should write and learn. Okay. Okay, now let me know if you have any doubts in this.